Good day, everyone. I'm Arvin Enriquez, your subject teacher. With this video lesson, we're going to discuss operations on functions under your General Mathematics from Quarter 1, Module 3. Our lesson objectives. At the end of this video lesson, you are expected to define operations on functions, identify the different operations on functions, and perform addition, subtraction, multiplication, division, and composition of functions. For our definition, let f and g be functions. So we're going to use this f and g as our functions. For number 1, so there's sum denoted by f plus g is the function denoted by wherein your f plus g of x is equal to your f of x plus g of x. So we just simply add your two functions involved, and that is your f of x plus your g of x. For number 2, so it's about subtraction. So their difference denoted by f minus g is the function denoted by f minus g of x is equal to f of x minus your g of x. So we're going to apply your subtraction between your f of x and your g of x. For the third definition, so their product denoted by f multiplied by g is the function denoted by your f of g of x now is equal to the product of your f of x multiplied by your g of x. So we just simply multiply, your f of x to your g of x. So if there's a given value or expression for this f of x and g of x, then we just simply multiply them, and that will be the product, that will be the definition of this kind of operation in function. So for number 4, their quotient denoted by your f over g is the function denoted by your f over g of x is equal to the quotient of your f of x and g of x. So we just simply divide your f of x here by g of x, and that will be the definition of the quotient as an operation, for this function. Excluding, so we need to exclude the values of x that make your g of x is equal to 0, because we really need to make sure that g of x is not equal to 0. That's why we need to exclude the values of x that will make your g of x is equal to 0, because we really need to make sure that your g of x or your denominator should not be equal to 0. For number 5, the composite function denoted by your f composite of g of x now is your f of g of x. Now, whatever your second function here, that will be your second function, wherein your g now will serve as your second function, and at the same time will serve as a value of all your variable x in your first function f of x. Now, if this is g of g composite of f, f is your second function, meaning to say, if f is your second function, that will be the value of your x variable under your g of x, which is your first function. So whatever your your second function, I mean, no, between your f and g, so that will be your x variable in your first function. So the process of obtaining a composite function is called function composition. So you need to take note of this. No. So the process of obtaining a composite function is called function composition. So for example, number one, so given the following functions, f of x which is equal to x plus 5, your g of x which is equal to 2x minus 1, your h of x is equal to 2x squared plus 9x minus 5. So using the concept of your operations on functions, no, we're asked to determine the following functions. So we're asked to determine your f plus g of x, your f minus g of x, your f multiplied by g of x, and your h divided by g of x. Then your e plus g of 3, your f minus g of 3, your f multiplied by g of 3, and your the quotient of h and g of 3. So we're asked to find the values of these functions, no, using the operation on functions. So for the solution, for letter A, your f plus g of x now will be equal to the sum of your f of x plus your g of x. So there is a given value for your f of x and g of x. We just simply copy these values of f of x and g of x, then we add them. For your f of x, the value of your given f of x is equal to x plus 5. And the value for your g of x is 2x minus 1. So since x here and your 2x here have the same exponent, which is equal to 1, same variable, same exponent, so we can add their numerical coefficient and we copy the variable x. So 1 plus 2, so that will be 3x. So 5 here is a constant from your f of x and negative 1 here from your g of x. So we just simply add these two numbers, so 5 minus 1 is equal to positive 4. So for our final answer for this f plus g of x, it's now equal to your 3x plus 4. Going to the next functions, no, your f minus g of x is equal to your f of x minus your g of x. So again, we just simply copy the value of your f of x here and your g of x here. So your f of x now is x plus 5, the same thing with your letter A. Then we copy your g of x, same thing with your letter A. The only difference is that we simply use subtraction as the operation between these two given functions, which is f of x and g of x. Now, we just simply copy your x and 5, so minus. So you need to make sure that there is a parenthesis involved when you are dealing with your subtraction for less confusion. So we just simply distribute this negative to your 2x and negative 1. So negative multiplied by 2x, so that will be negative 2x. So negative multiplied by negative 1 is equal to a positive 1 because negative multiplied by negative, it's a positive resulting value. Now, we just simply uh, add this positive x and negative 2x because they have the same variable attached to them, then there's same thing with the exponent. So x minus 2x, we follow the higher absolute value of a greater number, then that will be negative 2. So x minus 2 is equal to negative x. So 5 plus 1, they are both positive numbers, so we just simply add them. So 5 plus 1 is equal to 6. So our final answer for this letter B is equal to x minus 6, negative x, no, plus 6. So that will be your answer for letter B. Now, going to your letter C, which we can apply your multiplication on functions. Your f multiplied by g of x now is equal to the product of your f of x and your g of x. Again, we just simply copy, no? We just simply copy your given functions or given values, no, for your f of x and g of x. The only difference from your a and b is the operation between your f of x and g of x. In this case we apply your multiplication. So x plus 5 now multiplied by 2x minus 1. So we're going to multiply this one. So x multiplied by 2x, so that will be 2x squared. So x multiplied by negative 1, so that will be negative x. So there is a negative x here. Then we distribute your 5 to 2x minus 1. So 5 multiplied by 2x, so that will be equal to positive 10x minus 5. So again, we're going to put here your 2x squared as a product of your x and 2x. So here, the same variable involved for both your second and third term and same exponent, so we can add them. So negative x plus 10x, so that will be equal to positive 9x here. That's why it's positive 9x here. So that will be the reason why it is positive 9x here. So our final answer now is 2x squared plus 9x minus 5 for letter C. For letter D, your h over g of x now is equal to hx over your g of x. So we just simply copy the values of your h of x and your g of x, but we exclude, no? Again, from our definition, we exclude the values that make your g of x or your denominator equal to 0. So we really need to make sure that your g of x is not equal to 0. So upon copying the value of your h of x, which is 2x squared plus 9x minus 5 here, and we copy your g of x, which is 2x minus 1 in your denominator, no? We just simply get the factors of your 2x squared plus 9x minus 5, and we came up with these two factors, which is x plus 5 multiplied by 2x minus 1. So if you try to assess, so we can cancel this 2x minus 1, 2x minus 1 here from your numerator and denominator. So that will be equal to 1. So we can, it will never affect your final answer because 2x minus 1 over 2x minus 1 is equal to 1. Now, our final answer for this letter D is x plus 5. So that will be your final answer for letter D. So for letter E, So your f plus g of 3 now is the same thing with your f plus g of x. So we just simply replace your x by 3. So this will be equal to f of 3 plus your g of 3. So we just simply substitute your 3 to the x variables from your f of x and your g of x. Now, there are two ways on how we solve this f of 3 plus g of 3. First thing to do is to substitute 3 or replace all your x variables from your f of x and g of x by 3. So we can have now the two resulting values from your f of x and g of x. So if we replace x by 3 from your f of x, it's now 3 plus 5. So if we add these two numbers, 3 plus 5, so that will be 8. For g of x, we just simply replace this x by 3. So that will be 2 multiplied by 3 minus 1, or 2 multiplied by 3, it's 6 minus 1 is equal to 5. Now, since we have a value of your f of 3 and g of 3, now we just simply substitute this 8 and 5 as a value of your f of 3 and g of 3. So that will be 8 plus 5 is now equal to 13. So an alternate solution here, no? So we have known that f plus g of 3 means evaluating the function f plus g at 3. So a while ago, from your letter A, so there is a given value of your f plus g of x, which is 3x plus 4. So this will be your resulting value from your f plus g of x from letter A. So we just simply use it, and replace those x variable by 3. So we just simply copy the resulting value from letter A, then we substitute 3 as a value of your x variable to make it f plus g of 3. So 3 multiplied by 3 plus 4. So 3 multiplied by 3, it's positive 9. Plus 4 is equal to 13. So if you try to observe, in our first way on how we solve this f plus g of 3 is the same value that we can get from our alternate solution. And they are both equal to 13. So from your f minus g of 3, so from letter E, we know now the value of your f of 3 and your g of 3, which is 8 and 5. So we just simply use it, because it's the same function, it's the same value that we're going to put as a value of your x variable, both from your f of x and g of x. So since your f of 3 is equal to 8 now, and your g of 3 is equal to 5, then 8 minus 3 is equal to 3. So this will be our answer for your f minus g of 3 natin. So for your alternative solution here, your f minus g of x is equal to negative x plus 6. From our letter B a while ago, we get the value of this f minus g of x, which is equal to negative x plus 6. So we copy this one and we apply the value of 3 as a replacement to our x variable for this resulting value from your letter B. So we substitute 3 as the value of your x, that's why it's negative 3 plus 6. So we follow the higher absolute value of a greater number. So that will be a positive 6. So since the sign of your 6 is equal to a positive, that's why our answer here is positive 3. So as you can see again, it's the same value from our first way to our second way Now how we solve this f minus g of 3? Going to your f, no, that we can map again to your letter C a while ago, that f of 3 is equal to 8 and g of 3 is equal to 5. So we just simply copy, no, the values your f of 3 and g of 3 from your letter uh, E, no? So 8 multiplied by 5, it's 40. So that will be the value of your f multiplied by g of 3 natin. So for your alternative solution here, your f multiplied by g of x is equal to 2x squared plus 9 minus 5 from our previous example, which is your letter C. So we simply use the resulting value from your letter C, then we apply the value which is equal to 3 as our replacement, no, to your x. So we just simply substitute 3 as a value of your x to the resulting value from your 3 to become and to make it f multiplied by g of 3. So 2 multiplied by 3 square, now 9 multiplied by 3 minus 5. So 2 multiplied by 3, that will be 9 multiplied by 2, it becomes 18. So 27, 9 multiplied by 3, we copy negative 5. So 18 plus 27 is equal to 45 minus 5. So our resulting value for this alternative solution is 40. So it's the same answer from our first way on how we solve this f multiply of g of 3 here for letter G. So for h of g over g of 3 here, so we just simply copy the value of your h of 3 and g of 3. Now, we need to solve for the value of h of 3 and g of 3. For h of 3 and g of 3, so we just simply use the our function h of x. Then we replace all x variables under your h of x by 3. So it becomes 2 multiplied by 3 squared plus 9 multiplied by 3 minus 5. So 3 raised to 2, it's 9 multiplied by 2. It becomes 18. 9 multiplied by 3, it's 27 minus 5. So 18 plus 27 minus 5, it's 40. So the value of your h of 3 now is 40. Now for your g of x, this will be equal to your 2x minus 1. So we just simply use 3 as a replacement to our x variable under your g of x. So that will be 2 multiplied by 3 minus 1, or 6 minus 1. It becomes 5. Now, since we already know the value of your h of 3 and g of 3, then we just simply copy or substitute the values for your h of 3 and g of 3. It becomes 40 over 5. So 40 over 5 is equal to 8. So for the alternative solution, no, from letter D, the resulting value from letter D is x plus 5. So we just simply copy this one because this will be the resulting value from h over g of x from letter D. So right after copying the resulting value from letter D, then we apply 3 as a value of your x variable here. So there's an error here, so we need to put 3 here. So h over g of 3 is equal now to 3 plus 5. So 3 plus 5 is equal to 8. It's the same value from our first way on how we solve this h over g of 3. So composition of functions. So in composition of function, we will have a lot of substitutions. You learned in previous lesson that to evaluate the functions, yes, it is, no? You will just substitute a certain number in all the variables in the given functions. So similarly, if a function is substituted to all variables in another function, you are performing a composition of functions to create another function. Some authors call these operations as function of functions, because whatever your second function that will reflect on your composite function that will serve as your x variable in your first function. That's why they call it function of functions. So for example number 2, and it is under your composition of functions, so there's a given value of your f of x, which is x squared plus 5x plus 6, and h of x, which is equal to x plus 2. So we're asked to find the value of your f composite h of x and f composite of h of 4, then h composite of f of x. So there are three unknown functions here, so we just simply apply the concept of your composition of functions. For letter A, so f composite of h of x is now equal to f of h of x. So whatever your second functions here, that will serve as your variable x in your f of x or your first function. So this will serve as f of x plus 2. So we just simply replace all your x under your first function using the value of your second function, which is your h of x. Now, so since f of x is equal to x squared plus 5x plus 6, so we just simply copy your f of x, then we apply the concept of this composition of functions. So f of x plus 2 is now equal to x plus 2 squared plus 5 multiplied by x plus 2 plus 6. So here we apply the concept of special product. So we take the square of your first term, which is your x. Then this will be 4x, that will be your second term. So that will be the twice the product of your first and second term, which is your x and 2. So 2 multiplied by x, it's 2x multiplied by 2 because it's twice the product of your first and second term. That's why it's 4x. Now, for your third term here, so that will be the square of this 2, which is 2 squared is equal to 4. Now, we need to distribute this one. So 5 multiplied by x, that's why it's 5x. 5 multiplied by 2, that's why it's 10. So we copy your positive 6 here. Now we need to rearrange and to combine similar terms with the same exponent. So 4x, 5x now, they are both positive numbers, so we can add them so that it becomes positive 9x. So 4, 10, and 6, they are positive numbers, so we can add them. So 4 plus 10, it's 14 plus 6, it's 20. Positive 20. So our final answer for this one is x squared plus 9x plus 20. So your f composite of h of 4 is equal to f of h of 4. So step 1, we need to evaluate your h of 4. So by just simply putting 4 or as a substitute or as a replacement of x variable under your h of x. So we just simply substitute 4 as a value of your x variable under your h of x. It becomes h of 4 now is equal to 4 plus 2 is equal to positive 6. So this will be the value of this h of 4. Now, for step number 2, evaluate f of 6. So, if we're going to put 6 as a value of your under your f of x, so it becomes f of 6 now. So 6 squared plus 5 multiplied by 6 plus 6. So 6 squared is 36. 5 multiplied by 6, 30. We copy your positive 6 here, then it becomes 72. Now, once we apply your f composite of h of 4 now, f of h of 4 here, so we just simply use 6, no? Since it becomes f of 6 because the value of your h of 4 is equal to positive 6. So we just simply use it, then we use this one, no? And it becomes 72. It's the same process with this one, no? So for your step number 2, and this will be your last step. And to make it clear, no? Again, whatever your second function here, that will be the value of your variables in your first function. If h is the second function, so that will be your x variable values for your f of x because f is your first function. So for alternative solution, no, your f composite of x now is equal to f of hx. So we just simply use the value of h of x, which is x plus 2. So from our previous topic, so we simply get this one. So x squared 9x plus 20. So we just simply put no the x plus 2 as a value of your h of x to all x variables under your f. So it becomes 8x squared plus 9x plus 20. So it becomes, if we apply this f composite of h of 4, we just simply substitute 4 as a value of your variable x in this f of h of x. So it becomes 4 squared plus 9 multiplied by 4 plus 20. So simplifying, so 16 plus 36 plus 20. So our final answer is 72. So it's the same answer from our first way on how we solve this f composite of g of f composite of h of 4, which is equal to 72. So for letter C, your f composite of f of x is equal to h of f of x. Here, your second function is f. So we just simply use no the value of f of x as a value of your variable x in your first function, which is your h of x. So your h now is equal to x squared plus 5x plus 6. So since 8 h of x now is equal to x plus 2, so we just simply use this value. So we just simply use this value as a replacement, no, for this one. So that will be equal to what? So since your h now is equal to h of x squared plus 5x plus 6 is now equal to what? So we replace this one using this value. So that will be equal to x squared plus 5x plus 6. So we just simply copy this portion, no? For this value, which is x. So plus 2. So we copy your 2 here. Then we simplify. So x squared, we copy your 5x. So there is no other term with the same exponent from x squared to 5x. Then we add these two positive number, which is 6 and 2. It becomes positive 8. So our final answer is x squared plus 5x plus 8. So that will be your answer for H composite of f of x. So for the activity, determine whether each statement is true or false. So there is a given condition here that you need to solve, no? Applying the operations on functions. So we apply your subtraction, your addition, your multiplication, and division using the given function f of x and g of x. So you just need to determine if the statement is a true or false statement. You just need to prove and check if the given statement here is a true or false statement. So thanks for watching. Like, comment, and subscribe.